Welcome back, dear students. Today we are going to discuss on an important topic, that is the losses that is going to occur while you are doing the pre-stressing force in a pre-stress concrete member. That is losses in pre-stress. In a pre-stress concrete application, most important variable is the pre-stress. Pre-stress does not remain constant. It reduces with time because you cannot always provide. There will be some reduction in pre-stress, and that is called as your losses. Even during pre-stressing of tendons and transfer of pre-stress, there is a drop of pre-stress from the initially applied stress. Reduction of pre-stress is nothing but loss in the pre-stress. In other words, the loss in pre-stress is the difference between the initial pre-stress and the effective pre-stress that remains in a member. So which means I can say, when I am applying a pre-stressing force, what happens is there will occur some reduction or a small change in the length of the applied pre-stressing cable. If I am applying L pre-stressing length, then there will be some reduction delta L, and that delta L is the loss, or it is due to the loss in the pre-stressing force. That much force is not available, and as a result there will be some loss in pre-stressing. So you can see here the loss is mainly seen as the reduction of the elongation. So if I write, you can see the reduction of length is delta L. If I'm taking this as delta L, then the loss in pre-stress is delta L by L into ES. That is, this delta L by L is the strain. If L was the initial length we have provided, or the elongation we have provided, then delta L by L is the strain, and ES is the Young's modulus. So strain into Young's modulus will give you stress. So this delta L into delta L by L into ES is the loss in pre-stress, or you say that the losses in pre-stress. This only the concept is very much same, but only change will occur when there is frictional loss. Others it's same. Now the losses in pre-stress I can classify mainly into two. That is, one is immediate loss, that is straight after the application of this pre-stressing force, and time dependent, because it will take some time. The loss will occur throughout the lifetime of the structure. For immediate loss, I can say the loss due to elastic shortening of concrete, that is, the concrete will reduce its size, friction between the tendon and the tendon duct due to anchorage slip. And time dependent I can classify into three. That is, first one, the creep in concrete, that is the deformation due to sustained load. Shrinkage in concrete, it is a reduction in length due to the water present in it. Then the relaxation of the steel. The steel will get in the due time, the steel will get relaxed, and as a result the length of the steel will get changed. So these are the two main types of losses, that is immediate and time dependent, and the subcategories are given. We will discuss each and every one in detail. The first one, that is elastic shortening of concrete. We can see this in clause number 19.5.2.4 of IS 181343/2012. You can see that, you can read that. So in pre-stress concrete, when the tendons are cut and the pre-stressing force is transferred to the member, the concrete undergoes immediate shortening. You can see, you can imagine, due to this pre-stressing force, what happens. If I am having a concrete member like this, I'm applying a pre-stressing force. Suppose I'm applying exactly at the neutral axis. What happens? This member will get shortened by this much effect. Due to this pre-stressing force, what happens? It will get reduced. When I have cut this, it will get reduced, and this length will reduce. So I can say, suppose this was my original length, this L was my original length. There occurred some reduction in length, delta L1 and delta L2. Totally I can say is delta L is equal to delta L1 plus delta L2. So I can say the delta LC, that is the change just after the cutting the reinforcement, the pre-stressing force will be applied on the concrete, and the reduction in length of the concrete, I can say the delta, I will not say delta LC, I could write it as what? PL by AE, that is PL by AC into EC. That is your same. The same is happening. What this was my reinforcement. Suppose this was my reinforcement. This was my reinforcement initially. That much reduction has occurred to the reinforcement also, so that I can write delta ls is equal to delta lc, which is equal to pl by ac into ez, because that much reduction had occurred for the steel also. So loss in pre-stress, as I have said, the loss in pre-stress is equal to delta L by L into ES. So here I can write the loss is equal to delta LS by L into ES. That is, here I can write the loss in pre-stress is equal to delta L S by L into ES. But delta ls I can write as what? Is equal to PL by AC into EC. That is, I can write PL by AC into EC. That is delta ls into L into ES. So this and this will get cut. So which means I can write P by AC EC into ES. That is P by AC. That is your stress. That is pre-stress. I'll denote it as FC, the stress at the level of steel, into ES by EC is called as the modular ratio, that is M. I'll denote it by M. That is, I can write the loss in pre-stress due to elastic shortening of concrete is equal to M into FC or FC into M, where FC is a stress in concrete at the level of steel. So this I have discussed with respect to the eccentricity, the without eccentricity, with respect to the tangent at the exactly at the neutral axis. And if there is eccentricity, there will be some reduction as well as some increase in length, because when there is eccentricity, it is going to get shortened due to the force, direct prestressing force. It is going to elongate it due to this eccentricity effect, and due to the dead load effect, it is going to get elongated also. So a combined effect of that all is being considered, and we will consider the average stress in concrete at the level of steel if it is a tangent with eccentricity. So for time being, you understand the loss in pre-stress is equal to M into FC. If it is a straight tangent, it is directly stress in concrete at the level of steel, and if it is a pre-stressing cable with eccentricity, we will consider the average stress in concrete at the level of steel. Now if it is a post-tension member, in case of post-tensioning, if all the cables are tensioned simultaneously, then there is no loss, since the applied stress is recorded after the elastic shortening has completely occurred. That is, if we are having a post-tensioning, the first cable, suppose you're having the post-tensioning cable like this, duct was there, you're anchoring it here, you're keeping it like this. Now we will apply the force. Now after applying the force, what you will do is you will have the shortening will take place, and you will anchor it once the shortening has occurred. So there is, after the application of this force also, there is still P force is there. There is no loss in pre-stress due to elastic shortening if the post-tensioning cable is done simultaneously. That is, we are doing the post-tensioning simultaneously, or a single wire is only there and we are doing it. But if we are having multiple wires, suppose you are having multiple wires, I'll take a section over here. You're having multiple wires, like you're having multiple wires like this. That is, one wire here, then the other one, and the other one like this, and one more like this. So what we do is, the first wire will be wired, that is the red one, will be made like this. This is a section, okay. This half part, there is, it is being anchored at somewhere here. Now I will apply the force. Once this force is done, we will anchor it here. So it is done. We'll anchor it here. Now the second wire will be stretched. When the second wire is stretched, now this is over here. Now the second wire is stretched. Now the second, after second wire is there occurs some shortening, and we will anchor it somewhere here. So there occurred some delta L1 shortening. So for the first wire there occurred some shortening of this. Now the third wire is now being stretched. The third wire, that is this color, the third wire is now stretched, and it will be anchored somewhere here. So there occurred some delta L2 shortening. So now the total shortening happened for this red wire is delta L1 plus delta L2. For this yellow wire is delta L2. And the last one, now if I am stressing it, is the green color. If I am doing the freeze tensioning, what happens? Now this will be anchored over here, and there occurred some delta L3, which means the most loss will happen for the first wire, that is delta L1 plus L2 plus L3. The second most will be for this yellow wire, and third most for this violet. And for this red wire, sorry, this green wire, the shortening or the loss will be 0. It is equivalent to this one. The green wire is equivalent to simultaneously applying the pre-stressing force, or when there is only a single wire. So that now if you read this, in case of force tensioning, if all the cables are tensioned simultaneously, there is no loss, since the applied stress is recorded after the elastic shortening has completely occurred. We are measuring this P after this elastic shortening has occurred. The cables are tensioned sequentially, that is 1, 2, 3, 4 like this. Then there is loss in tendon during the subsequent stretching of one other tendons. You can see here the most stretched one, or most one which will be having losses will be this red one, that is the first one, and the least or 0 will be for the last one. So you can see here for post tension, if there are only one wire tension or single wire, or there are many wires but all wires are tensioned at the same time, then multiple wires or simultaneous tensioning, then you can see here there is no loss. We will calculate this P after this has been anchored. In post tension members, equal amount of force P is required to be applied over the concrete at the time of tensioning. Due to this P force, concrete gets shortened. Elastic shortening of concrete occurs at the time of tensioning itself. We can see here at the time of tensioning itself due to this P force. So reduction or reinforcement are anchored after this elastic shortening of the concrete has occurred. So there will no further shortening after anchoring the reinforcement. So there will be no loss of pre-stress due to elastic shortening of concrete. That is, loss of stress is 0 when it is done, or single wire is done, or simultaneously it is done. But if it is done sequentially, then there will be losses. So please make sure those things. The next type of loss is loss due to friction or frictional loss. So here this type of loss occurs. Suppose I am having a concrete pre-stressed concrete member like this. I am providing a parabolic tendon. The neutral axis of the tendon is like this. Now I am providing a parabolic tendon. It will be like this. It is moving like this. The profile of the tendon is parabolic. It's not straight, it is parabolic. That is, it is having eccentricity at the midspan and zero eccentricity at the end span. I'm applying the pre-stressing force from either ends. I am tensioning it from either ends. So you can see here, if suppose I am applying an initial force of P0 is equal to 1200 Newton per mm square from this end, and this end also P0 is equal to 1200 Newton per mm square from this end. So what happens is, this is moving inside a duct. This is moving inside a duct. So this is inside a duct. You can imagine this is inside a duct. So what happens is, there will be some friction between this duct and this reinforcing cable, and as a result, there will be a reduction in this pre-stressing force. Suppose this is 1200, there will be some reduction here, 1195, then some reduction here, that is 1180, some reduction here, 1170, some reduction here, at this mid 1160. Similarly here I'll be having 1195, here 1180, here 1170, and here 1160. So this reduction will occur, and this reduction due to this friction is called as your friction loss. And this loss due to friction is mainly due to first one, that is, as the length increases, you can imagine, you can see here, as the length increases, the friction loss also increases. So due to the length effect, this is also called as wobble effect. Due to length effect, the second one, you can see here, as the curvature increases, there will be two forces, that is a normal force and horizontal force. So the curvature also plays a major part in this, that is due to curvature effect. Due to curvature effect, these two affects the frictional loss in your member. So you can classify this. You can see in clause number 19.5.2.6 of your IS 1343/2012, friction loss. In post-tension members, the tendons are housed in ducts or sheaths. If the profile of the cable is linear, the loss will be due to straightening or stretching of the cable, called as wobble effect, or due to it's called as length effect. The cable profile is curved, there will be loss in stress due to the friction between the tendon and the duct, or between the tendons in themselves, and that you can see as the curvature effect. You can see as the curvature effect here. Now you can see here, the post-tension member, the tendons are housed in ducts or sheaths. So we can say for pre-tensioned members, there is no ducts at the time of tensioning, right? It is with the contact of this tendons is with air, so there is no frictional loss because it is in contact with air, and there is no friction between the air and the tendon, so there is no frictional loss for pre-tension member. Only for post-tension member, where there is duct provided or sheets provided, there occurs the frictional loss. And clause number 19.5.2.6, if you read, you can see the same thing what I said here. Loss of pre-stress due to friction. The design shall take into consideration all the losses in pre-stress that may occur during tensioning due to friction between the pre-stressing tendons and the surrounding concrete or any fixture attached to steel or concrete. You can see here, for straight or moderately curved structure with curved or straight cables, the value of pre-stressing force Px at any distance x meters from the tensioning end and acting in the direction of the tension to the curve of the cable shall be calculated as below. Px is equal to P naught into e raised to mu alpha plus Kx, where P naught is the pre-stressing force in the pre-stressing steel at the tensioning end in the direction of the tangent to the force, that is the initial pre-stressing force. Alpha is the cumulative angle in radians, that is how much angle we are providing. Mu is the coefficient of friction in the curve. K is the coefficient of wave effect. The value of mu and K are given in your IS 1343/2012. You can see in the tables. You can take the value for K and mu according to the type of cables used. And you can see here also, when I am pre-stressing from both the ends, the least pre-stressing force occurs at the mid-edge. But if I am pre-stressing from only from one end, suppose I am pre-stressing from only from one end, then the maximum loss will be occurring at this end, isn't it? Maximum loss will be occurring at this end. So this is pre-stressing loss due to friction. The third type of loss that can occur, or the immediate loss that occur for a pre-stressed member, is the anchorage slip. And we can see here, this also occurs only for post-tension members because we are not providing any anchorage for this pre-tension. We are just cutting it from the edge. So this also occurs only for post-tension members. You can see here in clause number 19.5.2.5. In most post-tensioning systems, when the tendon force is transferred from the jack to the anchoring ends, the friction wedges slip over a small distance. You can imagine that. Anchorage block also moves before it settles on concrete, because you are having your tendons like this. I'll take a section over here. You're having your duct. Inside that you are having your reinforcement. You're having your reinforcement like this. So there will be a wedge here. This wedge will slip to some extent, delta L. Suppose this wedge slips in this due to this anchoring, and this delta L will cause some reduction in length, and as a result there will be some loss in stress. The loss of pre-stress due to the consequent reduction in length of this tendon will occur due to this anchorage slip, and certain quantity of pre-stress is released due to the slip of the wire through the anchorages. The amount of slip depends on the type of wedge and stresses in the wire. So the loss of pre-stress due to the slip can be calculated as if delta L is the slip occurred, then the pre-stressing force, the loss, is equal to ES into delta by L, where slip of the anchorage is delta, that is delta L by L into ES. The delta L is the slip that has occurred, L is the length of the cable, then the P by A is the loss in pre-stress, you can see here. So that is the end of the pre-stressing loss due to immediate pre-stressing loss. Now we will discuss the time dependent pre-stressing loss, that is creep, relaxation of steel and shrinkage of concrete, in the next class. Thank you.